Welcome to tonight's video on Unit 7, Curve Sketching. First part of curve sketching is to talk about what it means for a function to be even and odd. If a function is even, that means it is symmetric to the y-axis. So you see here, if you notice like -2, 4, and 2, 4, the x values change, they're the opposites, but the y value stays the same. So the algebraic rule for even functions is that if you substitute in a negative x, you get the same function that you started with. Whereas for an odd function, notice it is symmetric to the origin, because if you have an x and y, the opposite x and y is part of the function. So that's why f of negative x equals the opposite of f of x if it is odd. So a couple things. All functions must have even and or odd symmetry. That is false. Like you could have x squared plus 2x plus 3. That is not even or odd. That is no function exists that has both even and odd symmetry. That is false as well. There are a few functions that are both even and odd. One of them that comes to mind is just simple f of x equals 0. That is an even and odd function. So now, how do we determine symmetry? Well, remember, we substitute in a negative x and we see what happens. So the negative x to the third is negative x to the third. Opposite gives me positive x to the third plus 2x. So notice this is not even because it's not the same as what I started with. Then to see if it's odd, I factor out a negative sign. And notice now when I factor out the negative sign, notice, I don't need those parentheses. Notice that it is the same as what I started with. Notice this in the parentheses is the same as what I started with there. So therefore, this is an odd function, since f of negative x is equal to the opposite of f of x. And therefore, it is odd, which means it would be symmetric to the origin. For this one here, notice if I put a negative x in, notice I get negative 2x squared plus 3 over negative x plus 1. So I know now that it is not even. When I factor out the negative in a fraction, I can only take it from one part, either the numerator or the denominator. You can't factor out the negative from both. That's like a positive. So if I take the negative out of the numerator, I get negative 2x squared minus 3 over negative x plus 1. So that means it is not odd, which means this is neither. In this case, no symmetry there. All right, so now that we know symmetry, we're going to put it all together and sketch some curves. And so there's an 11-step process here that you can follow along, and we'll go through as we continue this. The first thing that you want to do whenever you're graphing is you want to factor the numerator and denominator first if possible. So for example, here is x minus 4 and x minus 1 over x minus 2. The reason you do that is you want to see if anything cancels. Nothing cancels here, so we're just going to use the original function. So the first thing we want to do is find the domain, and that is from negative infinity to 2. union 2 to infinity, right? We want to find a vertical asymptote, and the vertical asymptote is what makes the denominator equal 0. So that's at x equals 2. The removable discontinuity happens if you cancel out something from the denominator, and in this case we do not, so we're just going to put none. The limit as x approaches vertical asymptotes, so for example, the limit as x approaches 2 from the left of the function. So what you're going to do to figure this out is you're going to put in numbers a number that is smaller than 2. So for example, 1.9, just right, almost 2, but not quite. So if I put in 1.9, into the function here, I want to see if it's positive or negative, because I know it's going to be an infinite limit. That's what happens when it approaches a vertical asymptote. But I need to know if it goes towards infinity or negative infinity. So for 1.9, notice this is negative, positive, so that means it's negative, over negative, which means it's going to go towards positive infinity. Now as the limit as x approaches 2 from the right, so if I choose numbers like, let's say 2.1, 2.1 is to the right of 2. So it's going to be negative over positive, which means it's negative infinity. And then the limit as x approaches infinity of the function, and negative infinity. Well, remember, we can do this by observing highest powers. If we go back to the original, notice it's going to be x squared over x, so it's 1 over 0. So that means it's going to be infinite. Now, to determine if it's positive infinity or negative infinity, we're going to choose a really large number for infinity, like 100. If I put 100 in, notice it's going to give me a positive number, so that means it's going towards infinity. If I put, as it approaches negative infinity, if I put like negative 100, notice I get negative over negative, which is positive, but over negative, so it goes toward negative infinity. Now, because the limits of the end behavior are infinite, that means there is no horizontal asymptote, but there might be an oblique asymptote, or there is an oblique asymptote, which means I have to find that by dividing. So I go x minus 2 divided by x squared minus 5x plus 4. So when I divide x squared minus 2x, subtract, I get negative 3x plus 4, and then it's minus 3. And remember, the remaining part doesn't matter. So my oblique asymptote is y equals x minus 3, the line. Now, oblique asymptotes and horizontal asymptotes can be intersected. So in order to figure out if they are, I set the oblique asymptote equal to the function, and then I solve. So when you cross multiply here, you get x squared minus 5x plus 6 equals x squared minus 5x plus 4. Well, notice cancels out and you get 6 equals 4, which is not true, right? So that means the oblique asymptote is not intersected by the function. All right, so then to find the x-intercepts, or actually, yes, to find the x-intercepts, we set the numerator equal to 0, so that means x minus 4 times x minus 1 is equal to 0. So I get x equals 4, x equals 1, so the x-intercepts are 4, 0, and 1, 0. The y-intercept when you put 0 in for x, you get negative 2, because it's going to be 4 over negative 2. And then you have to find the symmetry before we can graph. So symmetry means, remember, when you put a negative x in, you get negative x squared minus 5 times negative x plus 4 all over negative x minus 2. When you square that, you get x squared. Negative negative is positive. So therefore, this is not even. And then when you take out the negative sign, you can go x squared plus 5x plus 4, and then make this x plus 2. So that means it's not odd, which means there is no symmetry, because it's neither. Now, come up here to graph. So because of the information we have, for example, we have that x equals 2. We have a oblique asymptote at y equals x minus 3. So minus 3 is down here. And it's going to intersect at 3. So it's going to be like a straight line there. There you go. And then we have the intercepts. So we have 1, 0. And we have 4, 0, which is over here because 3 is right there. And then we have the y-intercept of 0, negative 2. So, and then we check, because our limit as x approaches 2 from the left is infinite. And we know that it's going towards negative infinity here. This makes sense. That's going to follow the asymptote. And remember, this asymptote, y equals x minus 3, is not touched or crossed. And then also, it's going to go up this way towards infinity. And then here, this one goes down toward negative infinity as it approaches 2 from the right. And then notice the limit here goes towards infinity to the right there. So therefore, there's our first graph. All right, so there's the graph. Now the last part. Finding where it's continuous. Remember, continuity is the same as the domain, unless there's something that replaces a restriction in the domain, which in this case there's not. So it's from negative infinity to positive 2, union 2 to infinity. And then the range. Well, if you look at the graph here, and notice the range, it goes from negative infinity to infinity, because basically it's all real numbers. All right, so that's the first one. Moving on to number 2. So when we factor number 2, it factors to x plus 3 times x minus 1 over 2x plus 5 times x minus 1. So right now you could do the domain. The domain is negative infinity to negative 5 halves, union negative 5 halves to 1, union 1 to infinity. Then cancel, and then you can do the vertical asymptote at x equals negative 5 halves. And then the removable discontinuity, because you canceled the 1, The only thing is now you have to put 1 into this. So 1 plus 3 over 2 times 1 plus 5. So at 4/7, that's your removable discontinuity. Now the limit as x approaches -5/2 from the left of the function. So when you do that, if you put in like -2.6, so -2.6 plus 3 over -2.2 times -2.6 plus 5. So that's going to give you positive over negative. So it gives you -infinity. And then the limit as x approaches -5/2 from the right, that's like -2.4. So it gives you positive over positive, which is equal to infinity. So now the limit as x approaches infinity, meaning as it goes to the right of the function by observing highest powers, you have 1/2, which is 1/2. And as it goes towards -infinity, it's going to be the same thing. So now that the end behavior limit is an actual number, that means the horizontal asymptote is at y equals 1/2, and there is no oblique asymptote. Now to see if 1/2 is intersected, you set 1/2 equal to x plus 3 over 2x plus 5. So you get 2x plus 6 equals 2x plus 5. 6 equals 5. That does not work. So the horizontal asymptote is not intersected by the function. So now you need the x-intercept, which set the numerator equal to 0. So you get -3, 0. The y-intercept, you put 0 in and you get out 3/5. And then for symmetry, so you put in the -x and you get -x plus 3 over, no need for the parenthesis there, -x plus 3 over 2 times -x plus 5. So you get -x plus 3 over -2x plus 5. So it's not even. And then when you factor out the negative, so it's x minus 3 over -2x plus 5, it's not odd. So therefore there is no symmetry. So now we can graph this. We'll get some space over here. Okay, so now we have our vertical asymptote at -5/2. We have a horizontal asymptote at y equals 1/2. Now we have our x-intercept at -3, 0. We have our y-intercept at 0, 3/5, and 3/5 is above 1/2. We have our removable discontinuity at 1 and 4/7, and 4/7 is between 3/5 and 1/2. So I'll put it there, 1 and 4/7. And then because the limit from the left of -5/2 is -infinity, it goes down. It's going to go towards 1/2 here, but not intersect. Then to the right of -5/2, it goes towards infinity. And then as it goes to the right, it's going to go towards 1/2 as well and not touch. So now, it's continuous on the interval from -infinity to -5/2, union -5/2 to 1, union 1 to infinity. And then the range is -infinity to 1/2, union, but then it's 1/2 to 4/7, because there's a hole there, and then union 4/7 to infinity. All right, so that completes our video on the first two. I will make a video for the next ones shortly.